You could potentially be creating inaccurate measurements in super fast rising or falling edge signals, and it's all to do with how you ground your probe. So today we're going to show you what causes the inaccuracy, how to reduce the effect using a tool you probably already own, and to demonstrate how much this actually affects a high-speed signal. When testing a signal using an oscilloscope, the standard choice of equipment is a probe with a crocodile clip like this. This is used to set the ground reference between the oscilloscope and a potentially floating PCB. But this long ground clip adds a noticeable amount of inductance to a high-speed signal that's highly dependent on fast edges. This extra inductance makes a fast edge look like it's overshooting and ringing when it's not, making your signal look incorrect. To solve this issue, you need to shorten the ground path as much as possible. This is done simply by using a ground spring or a ground blade, which slips straight onto the end of your probe. If you don't have one of these, look in the packet your probe arrived in. They usually ship with most probes and are forgotten about and put aside. As the ground spring creates a much shorter ground path, there is much less inductance in the probe, reducing ringing substantially. But you will need to make sure your PCB has a ground close enough to the signal that you're originally probing. To demonstrate this, I've got the Pico MSO training and demo board, which can produce a fast edge clock signal, which we can test using the different ground methods. If you'd like to follow along with your own training and demo board, go to section 4.1, probe and ground connection in the manual. Before we jump into our demonstration, make sure to subscribe to the channel for more Pico tutorials and then sign up to our newsletter for exclusive early access to all these videos. Back to the demonstration. So for the first test, we're going to be using the longest ground path I can make using a second probe and relying on the common ground between the two probes. This is going to create a massive overshoot with quite a lot of ringing. We'll save that as signal as a reference waveform and then test our second signal. For the second test, we'll use a standard ground clip, and you should see a smaller but still ringing edge, showing there is much less inductance in the ground path. For the final test, we'll swap to the ground spring and make sure it's touching the ground closest to the test signal. Now we can see what the signal actually looks like. It's a super fast, sharp edge with minimal amount of overshoot and barely any ringing. If we put all the reference signals on the same screen, you can see how much of a difference each ground path can make to the signal, and how much we're masking the original signal with all the extra inductance. So next time you're testing fast edge signals, make sure you use the smallest ground path possible, and see if you can find that little ground spring in the bag of probe accessories.